Hi again, Year 12, and welcome back to Miss Fisher's online video. For today, we are going to look at the mixed exercise 11 because we have now completed chapter 11, the 5 exercises from there. Please make sure that you have done those 5 before you look at today's lesson. So what I'm going to do today is I'm going to go through the challenge question because there's 2 very tough questions here that I want to show you. I'm then going to set you questions 1 to 6 to do at home and for you to send that into your teacher. And then I've got a little challenge for all of you to do, which I'll talk about at the end of this video. Something quite exciting. Okay. So let's look at this challenge. So I'm looking at challenge 1 on page 195 from the mixed exercise. So what challenge 1 says is, if I'm just written it out in full here, we've got a particle starts at rest and moves in a straight line, and we're given the motion for the acceleration with this formula here. Remember, it does start off at rest, and it asks you to find the distance moved by the particle in the first 5 seconds of its motion. Okay, so how can we solve this problem? So we know the connections between acceleration, velocity and displacement. So I can see this is not a Suvat equation because this acceleration is not constant, it's changing as time is changing. So I can't use the Suvat equations. So I do have to use calculus, I do have to use integration here. So what I'm going to do first of all, I know that I can get velocity by integrating acceleration with respect to time. So if I integrate my acceleration formula, this formula here, with respect to time, I'll get my velocity. So let's integrate. Remember, when we integrate, add 1 to the power, divide by the new power. Add 1 to the power, and this will become t. And don't forget your constant of integration, very, very important. Now, I know that the particle starts at rest. So at time 0, I know v is 0. So therefore, subbing those in, c is 0. So if I just tidy up this equation for velocity, I get this. Now, I want to now get my distance moved. Now, I could integrate this again because I know that the integral of velocity is displacement. However, I don't know whether my sketch of this graph, whether it goes beneath the x-axis, i.e. when the displacement is going away, the distance is negative. So what I'm going to do is have a look at the sketch of this velocity time graph and let's just see what's happening here. So to sketch this, I can see I've got a cubic. So let's see where the graph intersects the x-axis. So if I factorise, take out t first, and then hoping that my quadratic here will factorise. So just see if that factorises, guys. Yep, well done, well spotted, with a 5 and a 4. Okay, so I can see that when v is nothing, t is nothing, t is 5, or t is 4. So those are the values that it crosses the x-axis when v is nothing. So I've got a velocity, time graph, so nothing, 4 and 5. My graph will cross the x-axis. So let's make this a positive cubic. So I know it's going to go this way. So it will be something like this. Obviously I can't have negative time, so I wouldn't have that on my graph there. It's just going to be this bit here. Now, I know that the area under a graph, for a velocity time graph, I know that this area here will represent my distance moved for the first 4 seconds. And this area here will be the distance for the next second, from second 1 to second 4. So I can see from this graph that I have got a positive, this will give me a positive answer and this will give me a negative answer. So I can't just integrate between 0 and 5 to get my total distance travelled. I have to integrate this here between 0 and 4 to get the distance travelled here, and I have to integrate this here between 4 and 5 to get this distance travelled. So let's have a go at doing that then. So here's my formula for velocity, going back to what I originally got at the beginning of this question. I'm going to integrate with respect to time, and I'm going to integrate between, for the first, if I call the first distance S1, between 4 and 0. So let's integrate that, add 1 to the power, add 1 to the power, add 1 to the power. Now in this case, because I've got limits, I don't need to have a plus c. It's what we call a definite integration. Now if I put my 4 and 0 in, I would get 32 meters. So that's the distance travelled for the first section of the graph between 0 and 4 seconds. Now if I do exactly the same now, integrating velocity between 5 and 4, so exactly the same, integrate this formula here, which I've already done, I've already integrated it, between 5 and 4, I will now get this answer, 0.75 meters, which represents this distance. It's only negative because it's below the x-axis. So the total distance travelled, I need to add the modulus of both my previous answers. So I need to add 32 and 0.75 to get my answer for the total distance travelled. And that's the end of that question. So why that was a challenge is because you had this positive and this negative distance here. Okay, well done. Let's now look at challenge 2. So here is challenge 2 on page 195. So the question says a particle travels in a straight line with this acceleration. The particle travels 50 meters in the 4th second. And it says the particle travels, find the velocity of the particle when t equals 5 seconds. So, sorry about that guys, I just knocked the camera. Right, so I'm not given that the velocity is it starts at rest, so that I can't say the velocity is 0 when time is 0. It doesn't say that in the equation like it normally does. But I'm going to start this question exactly the same way that I started the last question, challenge 1. I know velocity is the integral of acceleration with respect to time. So I'm going to look at integrating my acceleration formula with respect to time. So add 1 to the power, divide by the new power, plus my constant of integration. Unfortunately, in this case, I cannot find c straight away because I haven't got the initial condition of what the velocity is when time is 0. So what I'm going to do now is I know that my distance travelled, as long as my velocity time graph doesn't go below the x-axis, if I just look at the 4th second, i.e. between 3 and 4 seconds, if I integrate my velocity, this equation here, I will get the distance travelled. And we're told that this is equal to 50 meters in the 4th second. So hence, once I integrate this, I will be able to find c because I know my solution. So let's have a go at doing that. So here's my velocity equation. Don't forget to put the plus c in. I'm integrating with respect to time between 4 and 3. So if I do that, I add 1 to the power, divide by my new power. Add 1 to the power, divide by my new power. Notice I show all the method. I don't try and cancel straight away because that easily makes errors. So please do this, follow this methodology when you're doing your own work. So if I just tidy that up, I've got this between 4 and 3. So if I put those two into there, put 4 in, put 3 in, take away my two answers, I will get 44 plus c. That's my total distance travelled. And I know that this is equal to 50. Hence, my c is equal to 6. Okay, hope you're with me so far. So now I can put 6 back into my velocity equation. So my velocity equation is this, going back to the beginning, is that. And the question says, find the velocity when t is 5. So all I have to do is put t equals 5 into this equation, and out pops my answer for velocity. Okay, so that's the end of challenge 2. Thank you for listening, and this is the work that I have set for you. If I can find it, I have put it somewhere safe, guys. I just need to rustle through my paper. Okay, well, I can't find it, but what I have doesn't mean to say I don't know what it is. So what I have set for you is to do questions 1 to 6, please, from the mixed exercise. I found it now, guys. So from the mixed exercise, I want you to do questions 1 to 6. Okay, do that with all your lovely method. Mark it all, please, in green. Highlight what you don't understand. Let me know if any more videos need to be made. Very happy to do that. Then it's your go to make a video. Yeah, don't panic, don't worry. I'm sure you can all do it. My son had to make one for a fitness video for PE. It did take him a long time for editing and everything, but it's something. He learnt a lot from it by the end of doing it. So I'd like you to make your own video. Have a go, okay? Any question, you choose which question you want to do from the mixed exercise. Anything from 7 to 13. Send me your videos, please. If you want to do more than one question, wonderful. But one question would probably be ample. Okay, guys, enjoy that challenge. Enjoy the rest of your day. And I cannot wait to see your replies. Bye-bye.